All right. I hope you guys can hear me. Um, Good evening, everybody. Good evening. Yeah, long time, long time, long time. I mean, I was out here on Saturday, and yeah, it was a tough time streaming. All right. Um, hi everyone. Thanks for joining. Um, it's been a busy week as usual. The last time I was streaming, it was yeah, there was bugs everywhere. On Saturday, I was streaming about Next.js, and we ran into lots of bugs, and I'm scared. I'm scared of writing code now. Right. And we're trying to do some things with Next.js, Drizzle, and databases and all these other things. Right. So I didn't do any JavaScript streaming last week. It was pretty much busy with office work and all of that. But today, yeah, we're good. We have an opportunity to at least we have some time together, and we can use that to study some JavaScript, right? And yeah, I plan to talk about um I just plan to talk about a few things. I wanted to talk about scope and closures, the idea of scopes and closures, and I wanted to talk about function object and the function constructor as well. Those are big stuff that they are not common. Closures are quite common, but function object and the function constructor, yeah, they are not quite common. So I probably just want to show us a little bit uh about them. And I'm thinking that maybe next time I get an opportunity to stream, I should probably talk about regular expressions. How many of us have an idea of what regular expressions are or what regular expression is? I'm just thinking that maybe we should just switch it around so that I can talk about regular expressions. I've been wanting to talk about regular expressions, getting to teach about like all the interesting details about regular expressions and how valuable regular expression is to how regular expression is valuable to us as software developers, right? They are quite very powerful, right? They are quite very powerful. So, but let's see. Let's hope we maybe we get the opportunity to do that. But for today, like I said, I'm just going to try to see if I can talk about closures. So scopes. How many of us understand or have an idea of what scope is in JavaScript, right? Or closures, what closures represent in JavaScript. How many persons have an idea of what that means? So the last time I did JavaScript, we talked about rest and spread, right? Rest and spread, right? The rest parameter and the spread operator. And we talked about how we can use them to create new objects, how we can use them to, to achieve um, various interesting things, right? Right in our code base. So, but today I will try to talk about closures, scopes, variable scope, and closures. So when we say scope, yeah, what does what do we mean by the word when we use the word um when we use the word scope? What do we refer to, right? If you come across the usage of the word scope, what do you think they are referring to? Mm, So the scope of something, right? The region of operation, right? The region of availability of something, right? That is, oh, this thing is only available within this region. This thing is only available within this region, or this thing is only going to be accessible within this region, and that's the big idea of what scope is. That is, scope in JavaScript refers to like a block of area that a particular variable is useful or available or meaningful, as the case may be, right? And Anybody who has had an opportunity to declare a variable before in JavaScript will definitely understand what we are pointing at when we say the word scope, right? And after that, we can then look at closures. Then eventually we can look at, lexical context, or what we refer to as the lexical environment, that is inside of JavaScript. How does all of these things come together, right? How does all of this come together to be useful, right, to what we're trying to achieve here? So I'm going to be creating a JS file. I'm going to share my screen. I think I'm sharing my screen already. I just need to make sure you guys can see my browser. So I also want to use the browser's dev tool today, just to be able to get used to some things. So inside of the browser dev tool, why is everything slow? I guess everything is slow. Hmm. So inside of our browser dev tool, and I'm going to be shuffling between maybe the browser dev tool and my VS Code. So here I can declare a variable, right? Maybe let's say letter A equals to maybe number 10, right? And throughout this region of operation, that variable should be available. And I can now say console.log inside of this place and say, give me a inside of. So I've created um something called a code block, right? You can see that on line 4, and now have something referred to as a code block. And now within that code block, I'm trying to ask for a. What do you think will happen? Do we know the value of a inside of this block? Will our code know the value of a within the block that we're operating? Oh, it knows the value of a. So again, but this is another very interesting thing, right? We can now we can redeclare something. Let's try to redeclare something. Oh. I thought I was sharing my screen. Mm, right. By now we should be able to all see my screen. So I was saying earlier that if you look at what we have right on the screen, we have a initially on line 1, and then we did right, and we tried to create another thing, all right, a block, right, and we tried to console.log the a, and we saw that the a was available to us. Okay, we're saying, oh, can we now redeclare here, right? Can we do something with a? We redeclared here, and we did a console.log of a, and now a is giving us what, 30. Now in today's class here, I am using Node.js to run, right, but I want to also test this behavior out in a browser, such that I also check what is going on within a working browser. Let's see. So here we have this here. Mm, see these people. Is it your computer or my computer? You're saying I should not paste something. Is it your computer or my computer? Which one? I say you should allow me to paste. You're saying I cannot paste. So now I'm gonna take this out of the picture and then we run with this alone. And we can see that it's still within this block understands that, oh, hey is there. But automatically, right, if we bring the code back and we redeclare, right, a, and we say let a equals to 30, all right, automatically, right, and so you can see what is going on here, that within this context the value of a is 30, and outside of that block the value of a is what, is 10. And so you must understand that code blocks actually are they help us to like they kind of like can help us to, you know, redeclare something, let you understand that, oh, within this block of this code, this is what is happening here. This is the value of what, this is the value of what, this particular variable. Okay, so a function, right, when we create functions, we can have variables inside of our functions, and we can also have what, variables outside of the function, which we always maybe call like local variable or global variable, right, as the case may be. So we can say that if we have a function to add, right, and let's say it has the popular what, a comma b, and we are returning what, returning a plus b right here. Now within this block here, right, our a only has value within this function, right? Outside of this place it doesn't have value. I can't go outside here and say console.log what, a, because the global environment doesn't have any what, a variable declared. Let's say I clear out this exposure here, all right? So that way I can't ask for a here. We could only use a within, right, within this function. And that's what we're saying, that the function is serving as a block now, right? That is, we can have variables within that block that are operating. And outside of that block, we also could have variables also operating outside of what, that block. Does that make sense? All right. And also, the issue of let and const, right? Maybe we should bring back the former code, right? The issue of let and const. We can't redeclare with const. That's the major problem. Let's say we used const here, right? Or let's just say we used const in both places. We shouldn't be able to do this, right? Because our application will be totally, absolutely against this behavior. It's not even against it though. But if I redeclare, it will be against redeclaring. Right? That is, assignment to a constant variable is not possible. I think something is really dragging my PC back. Let me just take out this automatic saving. So here you would see again that because of the way these variables are being constructed by default, so anytime we are using a const variable, because of the way the variable is being constructed, we then now have what? We then now have what? A behavior, right? We then have a behavior that, oh, you're a const, then we can't redeclare. or you cannot redeclare anymore here because it is a const. So code blocks, right, are quite important. That is the region of the availability of that particular variable, and also, right, the way we declare the variable matters, right? Whether you're using a var or you're using a let or you're using a const also goes to affect, right, the behavior of such variable, right? The let and the const, they respect the code blocks around them. If we were to be using var, right, var, in this situation here, if we were to be using var, yeah, I think var should also work. Yeah, would also work in this context. I think so. But there must be. Okay, I've not saved. Now I have to manually save every time. And I think that the only thing here is by doing console.log hey outside of this place. Now you can see a different situation that the moment there is a redeclaration that happens on this line, right, 5 here, right, the original value has been affected. Unlike when we had let and const, the original value was never affected. The original value still was intact, right? When we had what? The behavior of what? Our let and const. Again, let us look at let right here. And with our let, if you declare the variable, right, you would notice that you first get the 30 and then you get the 10. So 30 is working for the region, the code block of where we have 30 declared, while 10 is working for what? The outside word code block, right, of our execution, right? And that is very essential. Again, if we have another function here, let's try a function. And this function maybe is called change, right? And this function changes the value of what? A to be what? 30, or let's say 100 or 310. And we can call the function change, and we can still ask for what? The console.log of what? Our a. And so automatically when we call this function right here, and this function carried out a what? This operation here, it has changed the value of what? A, right? It has changed the value of a as expected, right? Immediately after that function is gone, right, a in a global scope has also changed as well, right? So again, when you're working within code blocks, understand how you declare your variable, whether you're using let or you're using var, right? And understanding, oh, is this a block or is this a function block, or what am I doing here? Am I changing any variable within this region of my code right there? So code blocks, again, they are denoted by the curly braces, right? And they also impact the behavior, right? And that is what we are saying, that this is a scope within this bracket here, right? The value of a, right, the scope, right, for a is what? Within that curly braces, and within that scope the value of a is 30 within that scope. And outside here within the global scope here, the value of a was first 10 based on the first declaration that we had here, and immediately there is a mutation that happened, right? With this change function, the value of a, the global value of a has changed to what? To 3 what? To 310. Does that make sense? So programming paradigms that helps us to create scopes, or that create scopes for us, like whether you're within your if statement, whether you're writing a for loop, whether you're writing a while loop, right? Those things create their own scope. So variables declared within those scope would actually have the value, maintain that value within that scope. And when you are outside of that scope, right, those variables will not have any impact on the way your code runs anymore. And that is why sometimes you probably will see us, or you probably have been in a situation where you have declared, hey, you have declared maybe something, right, equals to what? Null. You would have declared something equals to null, right? And then you write a if statement to create some things, right? Check a condition, and you can then what? Set that value to something, right? You know that what? Something was first declared in the outside scope. Now, within this if statement, we're trying to mutate or change the value of something into something that we can use, right? And the value of something will still be 10. And outside of this place again, the value of something will still maintain what? The 10, because this is just mutating the value of what? Something. That if statement is only mutating the value of what? Something. All right. So when we look at the word, um the world of nested functions, right? What is happening within the world of nested functions? So when we say something, right, is a nested function, right? A nested what? Nested function. That is a function that has another function inside of that function, right? Hmm. Let's see. So if we look at this structure here, let's look at what we have here. There's the function called outer, and it has a first variable declared with var, and the name of the variable is what? Outer what? Variable. Then we sort of can ask for this outer variable within the inner variable, right? And there's another function inside of that function called what? Inner, which is holding what? A inner variable. And I think when we call inner here, right, it will console.log outer, and I think we should be able to ask for something like this here. Okay, we are not calling the outer function. We are not calling the outer function. Or better still, can you see my terminal? Nobody can see my terminal because my picture is obstructing the terminal. Hmm. So we can say that node, we're doing closure, and you can see that now, based on the structure that we have, right, the inner variable is not available outside of this place, right? Because it is only inside of this place, and we have called this function and we are done with this function. So outside of that function, inner is not available anymore. Now let's write a very interesting word function called what? Add two numbers, and it's going to take value here, right? And it's going to what? Return another function, right? That what? That takes value b. Now, what is going on with this operation here? there is a function called add two numbers. When add two numbers is called, it will what? It will call another function, right? Initially, with this whole setup here, right? With this setup here, right? A is only supposed to be within this place. Like A, variable A is only supposed to be available within that flow here. But because in JavaScript, A is referred to as a closed variable, right? So it means that JavaScript is somehow very smart enough, right, to still keep this A for you, right? It will keep this A for you to what? To work within what? Within this flow of execution. And I think like what Sean said, right, in the comment, just like when you're calling, when there is recursion, right, when there is a function recalling itself, that it is that same function that was declared that we also call itself again, right? That is, it knows itself and it's able to what? Always what? Execute itself, right? Like in the memory, it knows that, well, I am this function, right? Factorial. I called myself earlier with 5. But I have to call myself with 5 minus 1, which is 4. I have to call myself with what? 4 minus 1. That ability to what? For it to always, okay, oh, I need to call myself, right? The same function, knowing that it has to what? To call itself. So something of that nature. So what we are saying here, that within this line 15, variable A, right, is available to us to use. But thanks to JavaScript and the way it handles closed variable, right? In the way it handles something called closure, A is not only going to available what within this line here, but A will always also be available, right, within what this place. So naturally, the way you would have thought about it is that A will be available here and B will be available here. But no, A is a closed variable that the computer will also be aware of within this structure here. So it means that if you want to call this function, we can always say what? Maybe let what? Had what? Had 10, maybe had 10, had 10, had 10. So if we say had 10 is going to be something like what? A function that we are passing 10. Now, this 10 is serving as what? What is 10? 10 is serving as what? Our A variable. 10 is serving as our what? Our A variable. So it now means that if we want to call add 10 is now a function, because this one, the instruction of add two numbers is that what? When you call add two numbers, I am what? A function. Okay. The picture is obstructing something. I think we can do without a picture for now, and we can put focus on code. Or yeah. I'm trying to. I'm coming, please. What can you see now? You should be able to see like a layout of me trying to drag and drop stuff. Uh, and I can then bring my screen. All right, can you see my screen now? All right. I think. right? You should be able to see my screen now, right? With my image not blocking the code anymore. Is that correct? Okay. So as I was saying earlier, that what A is now what a closed variable. A is a closed variable, and we are able to now what use A within what A here is a closed variable. That is, A is representing 10 here. A is representing 10, and it means that by default it will call what this O function, right? It will call this O thing here, and this O new function here, this function B here, right? Second function is inside this thing called hard10. So by default, it has called the first function. It should not remember variable A anymore. It has called the first function, and the first function has returned the second function. But because the second function is a function, right? Every variable of the first function will be passed alongside, right? That is, the whole execution context of the first function is what available for the second function to use, right? Including what the variable of that first function. So that is the reason why after we've called this 10 here, you can go ahead to also what do another operation by adding 5 to 10, right? We can do well to add 5 to 10, right? Why is 5? 5 is representing our B and 10 is representing our A. Now, the only reason why A is available is because A is a closed variable. We've already called function A. That function add two numbers. We've called it and that is gone. Computer is supposed to forget it, but we're saying that because of the way JavaScript is, there is something called closed variable that the computer is able to what retain the variable in the memory and pass it to what hard10. So as hard10 is going, hard10 is carrying a copy of A, expecting you to pass another value called B. Does that make sense? Right? Hard10 is carrying what a live copy of variable what A, always expecting us to call that hard10 function the second time with another variable that we now serve as our B, right? So in this situation, A is what is serving as our closed variable, and that is where the whole idea of closures came from. Does that make sense? Does that make sense? Hmm. Okay, beautiful. And so we can run the code, right? We can still run the code by um am I saving or have I saved? No, not yet. Oh, are we still calling that outer function? We're still calling outer function. And so we are able to see what the result of calling the two functions, right? Which is what 15. Can we think of another example? Can we think of another example? A function called what? A function called maybe make counter, right? Make counter. And this function here is going to what, return another function, right? Right. So here we declare a variable called what? Count to be 0, and we are passing what we're expecting this second variable here to be available inside of this the memory of this second function, such that we can now increment that count. So the first time we call that function, right, is what we can create what a counter, and when we create a counter, it creates the first variable 0, right? So when we call the console.log of what the second function, we're calling this the second time, right? It will, we need to do a console.log here, or yeah, it's going to console.log the return value. We'll see 0, right, as the case may be. We've not saved. Right, we're expected to see 0, right? But in the real sense, right, our number has been incremented, right? Let's use pre instead of post. So here, based on this behavior, we should see 1, right? Based on this behavior. Right? So what is happening? Make counter creates the first function called counter. And inside of the first counter, we set a variable count to be equals to 0. But anytime that variable that is called count is passed to counter, the variable that is called count is passed to what? The counter function. So that the second time you call the counter function, it then increments the count. So if I try to call the second time, right, it will take 1, keep it in the memory and pass it along and do what? Another increment, and I would have 2 here, right? And if we call it again the third time, and we keep what? Having what? So again, count here is serving as a closed variable that is made available to what? This function to be used. Hence, that is where the word closure comes from. Does that make sense? Right? Does that make sense? And that is the whole the total idea of what? Of closures. Now, I'm thinking I should use Chat GPT for something. Let's see. I want to bring Chat GPT to the screen, and let's ask Chat GPT for some favor. Right. Hmm. Can we see my screen? And can you see what I'm typing? So there is a very interesting idea or in JavaScript, which is what the execution context. And the execution context or the execution environment refers to what? The environment in which what JavaScript code is executed, right? Evaluated and executed. Now, our execution context, we have the global execution context. That is this is going to what happen whenever a global, right, variable or function is being accessed, right? Is the default, the base where code is executed, and is created when a JavaScript file first run. Variable functions are declared in global scope are accessible anywhere in the script. So that is the first execution what context, right? Global. Now the other one is what we have the function execution context. That is, this is created whenever a function is called, right? Each function has its own execution context. That is, each function has the idea of all the necessary variables that the function needs to be evaluated, right? And then we have what another one, which is what the eval execution context. That is, this is created when code is executed inside the eval function. This is less common and generally discouraged because of what? security what concerns. So another thing that is very important in execution context is what? The variable object or the lexical environment. That is, this contain functions, arguments, inner variables, declarations, and function declarations. In this case of a function, variable object is called an activation object and includes the argument as well as what? Local variables. So what the variable object is pointing out is that it's telling you that, well, for me to execute a function for you, I need to know all the parameters that this function needs to what? To be executed, right? So that is what is going to be inside what your variable object. Then we also need something called what? The scope chain, right? It needs to be aware of, oh, where is this particular variable useful and where is this variable not useful, right? Where can we call this variable? When can we not call this variable? So JavaScript, when we declare any variable, whether in a code block or not, or in a function or in a global scope, JavaScript needs to know, right, what is the scope chain, right? This is a list of objects that defines the context in which the variables, the functions are looked up. So it is through the scope chain that JavaScript knows that when you are asking for hey, I will tell you that hey is not defined because I have checked all the scope chain around me and I cannot find a. I don't know if that makes sense, right? The scope chain is what? Is initialized to what? To include its own variable object plus the scope chain of the outer context. So it is more or less like a link between the scope chain and the variable what object. That is, I need to know the scope by which I am going to be useful. So once I know the scope or the region that I'm going to be useful, then I can also keep a record of all the variables that you can call within my scope to make me functional, right? So when I know all the variables that you can call to make me functional or active, so both the scope chain and the variable object, they need to go hand in hand together, such that anytime you're accessing a variable, it knows the variable chain, right? That the scope chain, and it knows the variable what object that are associated to that particular what execution what context. And definitely we have what this, right, which refers to object for which the function is being executed, right? Now, why is all of these things important? Now, the reason why all of this is important is they help us to know when functions are going to be executed or when variables are going to be called. When you are calling a variable within your JavaScript engine, it knows that, oh, this variable is declared. Or when you call a variable that is not declared, it can tell you that, oh, this particular variable is not declared. So is that what? Operational awareness, right? That is why the execution context is key. And that is why it's also very important for us as the engineers, right, to be aware of what execution context. That is, for example, understanding the behavior of closure will help us to what? Know that, oh, this variable is still going to be available here when whether we are not calling the function or not. For example, hooks. Hooks heavily rely on closure, right? Hooks heavily rely on closure because you will notice that when you're calling a set state, how many of us here, maybe, I mean, most of you that I know should be writing React, right? So when you first call the use state the first time, that is the only time that hook knows the variable. Is that correct? Right? The first time you call your use state, that is the only time your what? That hook or that function knows the variable. But now it now gives you another function that is always going to be aware of what? Your state. Is that correct? Is that the way use state works? Right? And that is what? Closure. That is, it only takes a particular single variable, but that variable ends up being available to you every time there is what? A render, or anytime there is a set state, or anytime somebody calls what? The state updater function. And that is what happens with what? Our hooks. And it's heavily relying on what? The powerful nature of closure to always make sure that anytime you call set state, it knows what the previous value of that variable is, right? And it knows what every detail about that variable, such that what it's able to give you what the next value for the next call. And that is what happens with what? Our hooks. Now, let's look at what the execution phase, right? If you want to know more about all of these, right, you can check the ECMAScript 262 document, which talks more about like all the execution context and all the theoretical implementation, what was used by browser engines to implement the functioning JavaScript that we all have. Now we have execution phase. Now execution phase is what we have, the creation phase, while the JavaScript engine sets up what the scope chain and creates what the variable object. That is, in this place, what it's trying to do is combining your scope chain and the variable object together to determine what is the particular thing that I'm supposed to call now, right? And the combination of what the scope chain and the variable object is what JavaScript used to know that, oh, I should be calling add now. Oh, I should be calling what set state now, right? Because it knows the scope chain and it knows the variable object associated to what each of the scope chain and to the outer and to every variable that is within the whole execution environment. And the interesting thing also in JavaScript is that functions and variable declarations are hoisted during this phase. That is, every function, variable, and what variables, they are shifted up, right, to the top of what of your application. And that is what we refer to as what hoisting, right? Meaning that they are added to the variable object before the code. So when they are moved to the top, they are added to what the current variable object, such that what your JavaScript engine is aware of what when to call this thing and when not to call this thing. And we have what the execution phase. In this phase, code is interpreted and executed, variables are assigned values, and functions are invoked, and expressions are what evaluated. Now, the concept of hoisting during the creation phase, JavaScript hoists functions, declarations, variable declarations, right, to the top of their respective scope, right? This means that you can use functions and variables before they are actually what declared, because of what the ability of JavaScript to hoist all of our what variables. So closure is a function that retain access to what its lexical scope when the function is executed outside that scope. Closure is what a function that retains access to its lexical scope. That is, it has access to its variable even though it is executed outside of what its scope. This behavior is what possible due to what the scope chain. Now, understanding execution context is fundamental to debugging, working with asynchronous code, and managing memory efficiently within our JavaScript. So thank you, ChatGPT, for that, right? And we can also check something here, JavaScript info / scope, right, which also tells us more about what scope and what the execution context. Now, again, let's look at what our lexical context. Now, in the lexical context, we have variables, right? The computer needs to know what are the variables that are declared, right? Which is what the variable object and the scope chain. That is the first very important thing. So it needs to know, right, all the things that is necessary. Now, there is something called the global lexical execution scope, right, which we've talked about, right, earlier as well. So yeah, as the code starts executing, the lexical environment changes. Okay, so execution starts, the phase, right, is uninitialized. Then somebody declares a variable called phase, right? So phase is undefined, right? Somebody passes a value of hello to phase, right? So phase now has a value. Somebody redeclares phase now has by, and this is what just step by step of what happens within what the execution, what our execution what phase. Then also we have function declarations. Like we said again, for function declarations and variables, they are hoisted to the top of our application, and that is where what the whole hoisting, right, moving toward to the top of the global what chain or the scope chain, right, such that we are able to what to call them easily. So for function declaration, it is moved into the memory so that the computer is aware, the compiler or the transpiler that we are using is aware of, oh, this is a function called what. So when you look at the execution start for this phase now, the only thing that happens here is that what, it knows that what, phase is undefined, and it knows that there is say, which is what, a function. Those are the major thing that happens within here. And there is the inner and outer lexical environment. That is, the moment we call say, the computer will branch out and go and create another what, execution environment for what, a particular function called say. And inside of that place, it will try to also what, break everything down one by one. Oh, what are the variables within this place? That will be the list of the variable objects. Also, what are the list of what is the chain? How is the global like related to what this function say? When will say be called, right? In what, when will the say function be called in the global context and all of that? So all that details is aware. So the first thing is what, it knows that say is a function, and what, inside of say, it's supposed to just display face and name. But it needs to know what name is, right? What is the value of name? So it understands that, oh, the declared name to be John, then it knows that anytime I want to call the say function, right, I need to now know what say the phrase is, right? The phrase, such that I need to call the phrase and the name, right? So during the function call, we have two lexical environments, the inner one, which is the function called say, and the outer one, which is the global one, that is what calling say, right? Both of them needs to what, be aware of when to call each other and their variable, such that they know what, when to call what, each other, right? And that is the whole idea of what, function. So again, if we are returning a function here at the beginning, make each counter make calls a new lexical environment, right, is created to store the variable or what for this make counter to run. Then we have two nested next lexical environment, just like in the example above. So the first one is what, the lexical environment for make counter, and the second one is the global what, lexical environment that is going to be calling the make what counter. Now, inside of make counter, what is the variables there? What are the variable objects? The variable object inside make counter is what, count is equals to what, 0, right? And it also now knows that, well, inside of me, so what's the difference is that what, during the execution of make counter, a tiny nested function is created on the run, right, which returns what, another function, count plus plus, right? We don't run it yet, but we only create that function. So again, because it is returning this function doesn't mean it will call the function, right? It will just keep a copy of it, right, in the lexical what, that context, in the variable what object, right, and keep it in the scope chain, so that it knows when to what to call it. So all the functions, remember what their lexical environment in which they were made. Technically, there's no magic here. All functions have hidden property called what, like an array of what, environment, an array of environment that keeps the reference of what, the lexical environment where the function was what, created. So for here, the smaller function inside will have its own small environment, right? And inside of it, it will be aware of what, a count called what, 0, which is in the outside. And the one outside will also have an idea of the global thing outside, that, oh, there is make counter that is our owner. And it's only when they call make counter that they can now call me, the small count. And that's when the other small function can now return itself, right? So that way, each functions that are linked together, sorts of what, they know when this one should be called and when this should not be called. That is, there is a chain, a link, right? Which is what, that lexical context, the nested lexical environment, that, oh, this is the first function to be called. Then this one will call this next function, will call the next function, will call the next one function. So when we create counter now, this counter has we now have some environment, and that is when counter can know that, oh, inside of me there is count called what 0, and it is this count that our user is trying to what increase with what a post what increment, right? So the array, this double array of environment here references is what is set once and forever at function creation time. So later when counter is called, a new lexical context is created for the call and its outer variable reference that is taken from what counter dot what array of what environment. So again, another chain, right, of all the list of things that will be called right there. And so if you keep calling itself, right, once it has formed the necessary chain, then it can now start what the proper execution right there. So again, this is just to buttress what we've said earlier about closure, right? It's a general programming term called closure, right? That developers generally should know. A closure is a function that remembers its outer variable. A closure is a function, right, that remembers its outer variable and can access them. In some languages, that's not possible. Or a function that is written in a special way to make it happen. But as explained above in JavaScript, all functions are naturally closures. All functions in JavaScript are naturally functions, right? There is only one exception, right, to be covered, which is what the function constructor syntax that is not closure enabled. And also, even this one that is not closure enabled, there's a way for us to pass some variable to what the new function syntax, right? So that is, they automatically remember where they were created using their environment, right, property, and then the code can access what their outer variable. When on an interview, a front-end developer gets a question about what's a closure, a valid answer would be to define closure and an explanation that all functions in JavaScript are closures, and maybe a few more words about technical details of what the array environment property to show how lexical context or the lexical environment works. Garbage collection. What is garbage collection? Garbage collection is what the way JavaScript gathers all the variables that you have declared in the memory and how it disposes them, how it cleans them up, such that what when you are closed your browser or when you stop running a particular program, variables are not being kept in the memory again. They are discarded and they are no longer what useful anymore. That is, in what lexical environment is removed from the memory when all the variables after that function finishes call. Right? So immediately the functions and all the variable in a particular lexical environment finish what their operational usage, right? They are discarded, and that is when variables are garbage collected, and it happens automatically within JavaScript. We are not the one that handle it ourselves. It happens automatically within JavaScript itself. So that is that with what scope. We can try to play with some of these tasks here, right? You are able to you're just able to learn one or two things from some of these functions here, right? Right. The first time I wrote this kind of function in my life, I was I think I got a question somewhere and they asked me to write this function and I couldn't write it because I didn't know that anytime you see something that looks like this, they are referring to a function that calls itself, that returns itself. And it was around the idea of what? Closures. But I mean, we've come a very long way, right? Yeah, it's a lot. It's a lot of stuff there. So I also wouldn't want to talk about variables of VAR as the case may be, but the only major thing is that what VAR does not have block scoped, right? It tolerates redeclaration as much as possible. That is, when you declare variable within with var, it attaches it to the global variable, right? And var can be declared below their use because it will be hoisted to the top. And when we are within the high fe, that is the immediately invoked function expression, they are all what var, it has no block level visibility. Programmers invented a way to emulate it, right? And what they did was to call what an immediately invoked function expression. And I think that this way, right, nobody can have access to this message outside of this function, because this function is going to be immediately invoked, right? And immediately as it is invoked and you're done, it is garbage collected. So nobody would have access to this variable right here. And that is that. With that, also, you also understand that when we say global, right, the global in your browser environment is called window, right? That is, any variable you declare is attached to what global, right, your Windows object. And when we are within Node.js context, right, the global is what global this, right, is global this, right here. And yeah, that is that there. And also function objects. This is a very interesting thing. That is, anytime you create a function, I think I've talked about this too before, for those who have been following the stream very well, that anytime you create a function, there is a function object. That is, your function has a name. That is, you can use the name of the function dot name, and that will always give you the name of the function in strings, right? And you can also check the length. I think the length is supposed to show us the length of the variables within that function. I think so. Yes, the length property tells us how many variables, right, return the function parameters that we are using within that function. And we can also create yeah, we can create, like in this line here, they are attaching counter plus plus to what they are attaching. They are creating a custom property that we can add to what our function. So in this situation now, let's check our browser. So let's write some code. So here I can say what I can use make counter, and I can say make counter dot what dot sample, right, is equals to what special. And this way, right, I am attaching sample to what this make counter what object, and that is what I am trying to do there. Function properties can replace closure sometimes. Function properties can replace closure sometimes. So you can see that what instead of us using closure here, right, instead of putting a variable that will be closed here, we can use what we can create. You can, this is a function here. You can attach a variable to this function, right? Counter dot count, right? And because the function object is available whenever this second function is going to be called, so it means that when you call the first time, right, and the second time, it will absolutely work, right? It will absolutely work, all right? There. So that is that with that. And I think it also works within a function that is an expression. That is, when a function is what created and saved into a variable, it also works in there as well. And the last thing I wanted to touch on this stream today is the new function syntax, I'm going to show you an example of a place on GitHub where I have used that syntax, right? I think I used it in my Vue.js note. So for those who don't know, I also teach, right, Old School Africa, right, and I teach front-end engineering or software development in the first semester, and the second semester I teach React and all these other technologies that we use on the front end, right? So inside of setup, I have a code where I'm using the new function syntax inside of what? Inside of this runner. And if you look at it here, you would notice that what I think it is being used here as well. That is, we are constructing a function. Anytime you see this new function, what it means is we are constructing a function by using a function constructor, and you are passing it a string of what will be the content of that function. So what this is saying is that, oh, this function called component will be an arrow function, right? And that arrow function will what? Accept a particular variable called what? View, right? And it will return some information like a what? A string of what? Like some value, some scripts, right? That will be generated back to us. That's what it will what? Return. That is, no, sorry, that based on this, it will use this script and evaluate the script using this view function, this view global object here, right? And it will return some components, right? Some Vue.js distilled components that we can pass around. And the same thing here also within the React structure here, you would also see that what I am taking this function here to create what? An arrow function as well, right? And that function is going to be accepting React, and that's the reason why we're always passing React here, right? And I am what? I am calling a function, right? Whatever is inside of this result.code, it's going to be a function as well. And I'm also calling that function, right, within my old setup, right? So that is like we are immediately invoking whatever arrow function this function syntax create for us. So anytime you see this function syntax, right, it is a way to create new functions. It's a way to what? To create. So if you see the word new function syntax, right, it is used to create a fresh function instantly. So we can say that, look at this one now. I like this, but this is not the best it can be. So sum is going to be a function that we can now call with what? 10 and what? And 2. So what is this saying? Number one, this is the first parameter, this is the second parameter, and this is the body of the function, right? This also works. Now the second approach would be what? Let what? Sum2, right, to be what? A new function, right? A new function, and I am going to be returning I think I can return A comma B, right? And it can be something that looks like this. And this way, I can now call it this way. So is this line what? 42 and line 40, they are basically doing what? The same thing. And if we want to immediately invoke this, right, we can immediately invoke this by passing what? 20, passing 20 and what? 78. JavaScript is very beautiful. Very beautiful. Such way. So now, what are the situations where we will be needing this what? Function constructor? And the situation where we'll be needing this function constructor is when we have a situation where you cannot really call a proper function, right? You can only create a string of that function and immediately invoke it out, right? And those are what? The lexical context where the constructor function, right? The constructor syntax is very, very handy. And I think we can call sum 2. Okay, it has to be called twice. It has to be called twice, invoked twice. Right? It has to be invoked twice. Yeah, I think this works. This is because we are immediately invoking it, right? So, but if we are not immediately invoking it, we can, I think we can leave it here. If we are not immediately invoking it, I think so. Let me confirm. Okay, so it has to be called twice as well. So it's supposed to be the final thing here is supposed to be. And this is supposed to work. So this is the what? The new function what? Constructor. That is, it helps us to construct function anytime we have a string. So anytime you have a string idea of what the function is going to do, right, then you can what? So what happens here? Why am I using it on this particular thing here? Why am I using the constructor function here? Now the reason why we're using the constructor function here is because I don't have a script tag where I can what? I can call React dot what? React dot create, right? Because what I'm trying to do here is we're trying to what? We have a particular code, right, that has been written in React, which is what? The result dot code, right? But we need a way to call that code because again, you know that in React components are actually functions. So we need a way to call that what? To call that component, right, as a function, right? So that it will give us the what? The code, right? The generated code. That is, it will convert the JSX and give us the proper JavaScript generated version of that React, such that is the generated version of that React that we can then go ahead and use to what? To create our what? To pass to what? React dot create root. So something of that nature. I cannot create a script tag here, or I don't have a bundler that can help me to that I can use to execute the code within this portion of my code. And that is why I am now using what a constructor function as a string, right? Such that that will give me an arrow function that I can immediately invoke to give me the component that is generated. And once the component that is generated, I have that, then I can now send the generated component down back to what? React.create element and pass it to what? React DOM, such that React DOM can help me to what? To render it, right, in the React context. But when we are within the view context, whatever component that we have, we send that component to what? View.create app, right? So that view creates the app out, and then we attach that whole thing to our document, right? To a particular what? Div, right? And we are mounting, right? We can mount, right? So that is the reason why we're using what? The constructor function. It's a very technical syntax to wrap your head around, right, at the first go, but subsequently you can always you can always get familiar with it by writing the small versions, right? Just write the small version, right? You have the new keyword, you have the function, right? You open your bracket, then you have your string, and you close it, and you immediately revoke it. And the body that we have is what will be what will be what return. So most of the time here, you want to return an arrow what function, right? That is there. So you want to return a comma what b as the variable, right? And you want to return what? A plus what? Plus B, right there. And so sum is now a function that we can use, right, in our code. And we can say sum with what? 10 and 20. And we have 30. It is pretty powerful. It is pretty powerful. And the second approach is to create what? To use it as what? To pass it one by one. So you can say sum2 is equals to what? A new function, right? And I can pass it the first parameter, right, which is, I think, is this supposed to be a string now? Mm, yeah, all of them are strings. All of them will be strings, right? So we can pass it the first thing, which is A, right? The second parameter, which is what? B. And we can now tell it the body of the function, which is also a string, that is return what? A plus what? B. And we can, we have this, and we can say sum 2, right, is an anonymous function, and we can pass what? 10 and what? 20. And such a beautiful way to also write code. Such a beautiful way to write code. So let's try another dangerous one. Let's do a closure based one, right? A closure based one, that is a function that return another function, right, which is what? Hard. And we want the hard to be what? A new function. And it's only going to take, let's use the string approach first, and let's see whether we're able to get this to work. So it's going to return another function. It's going to be like this. The first variable is going to be a, right? And that is supposed to return another thing called what? B, right? And we can then do a plus what? B. So this way, right? This way, I think we should have something this way. So hard is supposed to be a function we can pass 10 the first time, right? And this second time we can pass 5, and it absolutely works. So it is very beautiful, very powerful, right? It's a very powerful function that you can also add to your toolbox as part of the things that you are aware the JavaScript can do. So today, high level, we've talked about what we started talking about, the idea of scopes, blocks, and closures or closed variable. From there, we moved on to talk about execution context, that is understanding the global context and the function context and all the all whether a val context, right? And what all these context means, or environment, context or environment, what it means is that JavaScript creates something we call a list of all your variable and a chain that links the outer what, the outer context to the inner context, such that JavaScript knows the exact variable to be called at every particular point in time, right? And that is what we talked about. Also, from there, we moved on to talk about the function object. That is, anytime you construct a function, right? Anytime you construct a function, you can say function.name, right? That is, a function will always have name, and a function will always have length, right? Length will always tell us what? The length of what? The parameters that you can pass. And you can also customize what? Send it a customized variable, right? Give it what? A particular value, right? That way, right, we are able to understand what happens to. So, and we also say that in place of using closure, that we can use a custom variable attached to a particular function to make that happen as well. This is what I am saying. I'm saying that instead of the make counter that we have, where's the make counter that we have here? So instead of using this close variable as let here, right, we can close this up and use what? Give this particular thing a name, right? Give this function a name, right? And say counter, and we can now say it will be what? No, is this the right way? Let me think about this. Let's think about this very well. I'm wrapping up already. I'm trying to just remember everything that we talked about. Okay. Yeah, yeah, yes. I think I remember now. So yeah, when we are done here, this can be what? Counter counter dot what? Count plus plus. And we can now see what? And you can now set this now. Because by the fact that you have created this variable called count here, you're telling JavaScript that you are aware of this. And I think instead of using this here, we can also decide to use the pre version of this. And I think it should work. Right? I think everything should work perfectly well. Say not a number. It has to work now. Still not working. Why is it not working? Hmm. Why is it not working? Okay, okay. Look at me. Look at me. Look at me. Look at me. So I can't return now because when we return here, it doesn't wait for the last variable here. So we can then return counter and it will work absolutely perfectly. Now, but the value is all one because it is adding one every time. Hmm, let's see. Okay, it now works perfectly, just the way it should work. So that is using custom properties in place of what? Closure. Using custom properties in place of closures. Guys, the idea of all of this is to help you to be able to eventually write code in a much more efficient way, depending on the environment you meet yourself, whether you're writing code on the front end or whether you're writing code on the back end. The goal of all of this is to just give you the various way to understand that functions are powerful. They are one of the bedrock. As objects and functions, those two things are the bedrock of JavaScript, right? If you understand those two things, right, your journey in JavaScript will become very easy once you have that solid understanding of what closures, functions, objects, and all these technical conversations. So thank you for joining the stream. Tomorrow I'll be back with Next.js, and I think we will not be using Drizzle anymore until I'm able to figure Drizzle out. Right, we'll just continue building the authentication flow and the registration flow of the app that we're trying to build. Right, because we're time is really against us, or we're against time, whichever one. So the idea is I will go ahead to use the normal credentials, right, or the external providers like GitHub. I think I'll use GitHub and Google as well, just as an example. All right. So if you want to learn more about Next.js and React, HTML, and all the beautiful thing of building full stack application with your JavaScript skill, you can join me tomorrow, right? I think around 3 p.m. Eastern time or West African time. I will be streaming on the same channel. Right, you can invite your friends to also join if you have anybody that is learning React or Next.js. Thank you for joining and have a wonderful rest of the day.